We are trying to find the horizontal distance x, which it travels after it leaves the table until it hits the deck. Ooh, guess what this is? Kinematics. So, what kind of kinematic problem is this? So we have this again. So we have, what do we call this when we have something shooting off an edge? Starts with a P. Projectile motion. And what do we always do if we have projectile motion? Make a table. So we have a table. Here's x. Here's y. Delta x I'm looking for. Delta y. What is delta y? 1 meter. All right. What kind of projectile motion is this? This is a horizontal projectile. Why is that important? So the initial y velocity equals 0 meters per second. So Vy naught equals 0 meters per second. What is the acceleration in the y direction? 0. The acceleration due to gravity. Excellent. So this is g. Now it's up to you guys right now. We can put positive 10 meters per second squared and make this 1 meter and assume the downward direction is positive, or we would need to make both of these negative. What do you guys prefer? Positive, you bet. So then we can get the time now. So I know delta y equals Vy naught t plus 1/2 at squared. What happens to this section? That goes to 0. So therefore delta y is 1/2 10 meters per second squared times t squared. Oops, I know the delta y. Delta y is 1. We're going to plug all this in. So I get what? We want to move all this around. Take the square root of both sides. What do you get for t? Hopefully 0.45. Everybody agree? Now, if this is 0.45 seconds, what do we know? We know that the x time has to be the same. Okay. Time does not change with direction. What is the acceleration in the x direction? It's 0 meters per second. It's in the air. We have no forces working on this to accelerate, which means that my initial x velocity is equal to my x velocity always. What is my initial x velocity? This is going to equal 4.3, so let's do a little sideline. My initial x velocity equals the final from part B. Okay, so at C, the final velocity, remember the speed of the ball just before it leaves the edge of the table, that was 4.3. That's going to be my initial velocity here then. So we know delta x equals Vx naught t plus 1/2 at squared. But what happens to this part? This is 0. So if I'm looking for delta x, I just plug in 4.3 meters per second times the time, 0.45 seconds, and delta x equals 1.9 meters.